Hi guys, sorry I couldn't be there. Last minute they told me I had a Hope Squad meeting, 7th bell. So I'm going to go through these completed notes with you. So this is exactly the presentation I would be doing with you if I were in class. So I would get out either your spiral notebook or a sheet of notebook paper so you can jot these things down. Today's stuff is pretty basic. It's just how we classify numbers in sets and how we do different notation, whether it's interval notation or set builder notation. So it's a lot of just notation, symbols, that kind of stuff today. Some of this you may have heard of already in Algebra 2. So for some of you, it may be a bit of a review. I'm actually going to start down here with real numbers. So the symbol for real numbers is just like the double line here and an R. Real numbers are basically any number. You may have heard of complex or imaginary numbers. That does not fall in this category, but we're just talking real numbers, no special cases. So every number is a real number. So that's used quite frequently. But then we can get more specific. So here, and unfortunately it's not going to let me write, so I'll try to talk slow. Or will it? No. I don't know. A natural number is what I like to call a counting number. So it's anything we can count. We cannot count 0 things. So it would start at 1. So your natural numbers are 1, 2, 3, 4, 5, 6, and so on. There are no decimals. We can't count 0.4576 of something. So natural numbers are just anything you can count. A whole number is basically a natural number and also 0. Okay, so a whole number would be numbers like 0, 1, 2, 3, 4, 5, and 6, that kind of thing, and so on, all the way to infinity. So a natural number and a whole number are very similar because whole numbers are natural numbers, including 0, though. An integer, which they call z, and the notation for that is just the double line here, and then, your normal z. An integer is any whole number, both positive and negative versions, though. So it's like -10, -2, -1, but it also includes stuff like 1 and 2 and 3. So it's both positive and negative numbers. So that's an integer. A rational number, they denote it with a Q, and then instead of just the 1 line, they put 2. And you may be asking why Q. Q stands for quotient, because what a rational number is, it's our pretty numbers, like our pretty fractions, I should say, like a half, because that's just 0.5, or 3/4, because that's 0.75. It's any decimal that ends or repeats in a pattern, like 1.333. That's a rational number. If it was something like 0.5757, that's a rational number. So a rational number is any number that results, it's dividing something that results in a whole number, or any integer, I guess I should say, because it could be negative. So when you divide two numbers, if it's any integer, or if it's a fraction or decimal that stops or repeats in a pattern. Okay, and I have examples on the next slide all out. These were done up already, and I don't have them on this actual page. But so a rational number is any integer, a fraction that stops, decimal that stops, or repeats in a pattern. We already talked about real numbers. And then the last one is an irrational number. So if you're not rational, you're an irrational number. And that's just any time you divide two things and it does not make this nice clean-cut fraction or decimal and does not result in a whole number, but instead turns into this crazy decimal that goes on forever and doesn't have a pattern. So an example of an irrational number would be like pi, or the square root of 3. Okay, so we have our real numbers, we have rational, irrational, and then the rational gets a little bit more specific, which I show you here. So this is a nice little, just kind of like a graphic organizer of how all the numbers kind of like fit together. So everything is a real number, as I've said. Then you either have your rationals or your irrationals. Notice we have examples of rationals here. Here's some examples of irrationals. And then if you are a rational number, you will either be an integer, which is negative numbers, or a natural number, which is our counting numbers, or a whole number, which is our counting numbers in addition to that 0. Okay, so that's kind of how it all relates. The next thing all deals with interval notation. And I think you've seen this before in algebra too. So if you have your bracket, when you're talking about the interval of numbers, like from where to where does it go? Where does it start? Where does it end? If it has a clear-cut end, or you want to include a value in it, you're going to put the bracket at the end or at the start. So if you want to include a value, if it says less than or equal to or greater than or equal to, you're going to have to include that bracket. You're going to use a parenthesis if you don't want to include that value. So if it's just a less than sign you see, or a greater than sign you see, and a parenthesis is always used for infinity. Okay. So this is what interval notation looks like for this. Okay, so we call this inequality notation, and this is interval notation. I believe for your assignment, you have to know both. So this says x is greater than or equal to 4. You should be very familiar with that. That means I'm starting at 4, and I'm including any value bigger than 4. So I'm going to go from 4 all the way to infinity. It's anything in between there. So I wanted to include 4, so I have to put the bracket, and I'm going all the way to positive infinity. But with infinity, we always use the parenthesis, okay? So this is an example of interval notation. Here's another example. X is less than 4. So I know I'm going to start at 4 again, but I'm going to go less than. I'm going to go to the left, to the negative direction. So I don't want to include 4. That's why the parenthesis is here. And I'm going to go all the way back to negative infinity. It just tells me to keep going on. And again, with infinity, you just close that. This one, since it's a little bit different, you're going from 3 to 9. So you're just talking values in between 3 and 9. You don't want to include 3, but you do want to include the 9 because of equal to. So that should be pretty straightforward. That's just interval notation. Sorry, I'm trying to not go too fast. I only get 15 minutes for recording. The next thing is set builder notation. So this is essentially it, and this is the example up here. So I'm doing x is less than 4. So it didn't ask for interval notation, it asked for set builder notation. So what you do, you always put your little curly bracket. You always put the variable you're using. So in this case, it's x. It could have been n. It could have been y. It doesn't matter. It's whatever variable they're using. Then you draw this line, and that line means such that. And then x is less than 4 is just the condition. That's what the problem gave me, right? So that'll change based on your problem. And this is probably the most difficult part of it all, and it's not terrible. You write x, and this little e means is an element of, and this is the kicker. You have to figure out which symbol. Is it a real number, a rational number, a natural number, a whole number, irrational? What am I going to use for this problem? So in this set, it's saying any number less than 4 is in this set. So that can include positive numbers, because 1, 2, and 3. It can include 0. It will include negative numbers, and it'll also include any decimal in between that, whether it's a nice, pretty, clean-cut decimal or a decimal that goes on forever. So for this one, you can't be very specific. You just have to say it's a set of a real number, right? I can't say it's an integer because it also has to include positives. Hopefully you get that point. So a lot of them end up being real numbers. A lot of times you'll see the R at the end. This example here, okay, our variable is x again. So we start with our curly bracket, x, such that this was the condition given. X is greater than 3, but less than or equal to 9. So you have to think again, what numbers are going to fall in between there? You know it's going to be between 3 and 9. So you might be thinking, well, I know it's going to be positive, so why do you have x as an element of a real number if it's not going to include the integers? And here's why. Because it can include any decimal in between here, right? 3.1 is greater than 3 and less than or equal to 9. 3.12456, you get the point, is greater than 3 and less than 9. So since it's going to include my rationals and irrationals, it's going to be a real number. Okay, so I can't be very specific. So we just say it's a real number because it's going to be in between those. Whole numbers, natural numbers, it's pretty much everything. So it's going to be just an element of real numbers. All right, this one is a little bit different. So notice here we just have numbers listed out. And you can see that they're all multiples of 2, right? 2, 4, 6. Same thing here, it goes in the negative direction. So for the set builder notation, I would say x. You could have used any variable on this one because they don't start with 1, but x is so common. X such that x is equal to 2 times n. And I knew to write that. You should have done maybe something like this in Algebra 2, that I can put any number in for n and it would work out here. So like when n is 0, 2 times 0 is 0. When n is 1, 2 times 1 is 2. When n is 2, 2 times 2 is 4, and so on. And it would work in the negative direction. Because I have specific numbers here, and I'm not saying it's in between this value to this value, there's not any equality symbols, we're not going to use the real numbers. We're going to say it's going to be an integer that we use. So n is going to be an element of the integers because I'm not using decimals. You didn't hear me say 2 times 0.5, right? So to get a multiple of 2, we're only going to use integers. The negative integers get me the negative numbers here, and then when they're positive, it gives me the positive. So you're going to notice here, whenever you see an inequality, that's when you use the real number. Whenever you see a list out, you can be more specific and be more specific here in this notation. I know it's going to be an integer, right? It's going to be a negative or a positive number. And these two are similar to my last two examples. So I'm using x such that you write the condition. And again, it's an inequality. So it includes decimals. So you're just going to say real numbers. X is all positive integers. That was the condition. And so you can say x such that x is a natural number, or when x is greater than 0. Both these ways would work. If x is greater than 0, it's obviously positive. And then either way, you can either say it's a natural number or it's an integer, as long as you classify that x is greater than 0, because integers can also be negative. I personally would have used this top one, that I know x has to be one of my natural numbers. It has to be a counting number, like 1, 2, 3, 4. That's how it's going to be a positive integer. And that is it. We were going to do whiteboard stuff today. I will post these worked out, so you just have some more examples. These were from last year, so it's not all completely done out. Please do not hesitate to email me or text me on Remind, or even stay after school. I'll be back in my room right after the meeting. In order to do that set builder notation, you really have to know what these mean. Like I said, though, most of them are just a real number if you're talking an inequality, because you have to include those decimals. But anytime you don't want decimals to be involved, you have to be more specific. And it's either going to be an integer, a natural number, or a whole number. Okay, but that's it. Like I said, do not hesitate to ask questions. I will take questions before we start class tomorrow. But that's it. I hope you have a great day.